Hello, good morning students. So welcome back to the video again. I hope you people have learned and gone through this formula. Please do remember this formula by heart, okay, as well as the previous 4 formulas also. And yesterday I forgot to mention this formula. Please note down this formula. Integration of dx is equals to x plus c. Okay, so integration of sin x minus cos x. Cos x is sin x. Integration of sec square x is tan x. Integration of cos x square x is minus cot x. Integration of sec x tan x is sec x plus c, and integration of cos x into cot x is minus cos x plus c, and the last one, integration of dx is equals to x plus c. So please do learn the formulas by heart. And now I'm starting with exercise. Okay, the same exercise, but question number 4 we haven't done, isn't it? So I'm starting with 4 part 1. Okay, in question number 4 part 1 we have integration. In 4 part 1 we have integration sin x divided by 1 minus sin x square. So what is my integrand? My integrand out here is sin x divided by 1 minus sin square x. And now we know what they mean by 1 minus sin square x, isn't it? So 1 minus sin square x, the value is cos square x, using the formula sin square x plus cos square x equals to 1. We know that formula for sin square x plus cos square x is equals to 1. So therefore 1 minus sin square x will be cos square x. Okay, now this cos square x I can write it as cos x into cos x, which is like this, isn't it? Sin x divided by cos x into cos x. Now what will I do? Now I'll separate. Sin by cos is tan into 1 by cos is sec. Okay, so hence we get tan x into 1 by cos. Now 1 by cos will be sec x, isn't it? So sec x into tan x. And I've given the formula. Formula number 9. Integration of sec x into tan x is sec x plus c. I hope you're clear with this. Pause the video to note down and practice it properly. Okay, question number 4 part 2. Question number 4 part 2. The hint I've given out here, please use the formula for cos 2x. We know cos 2x has 4 formulas. There are 4 formulas for cos 2x. Cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 2 tan x divided by 1 minus tan square x, isn't it? So all those formulas, but the hint I've given out here for 4 part 2, and I'm starting with 4 part 3, okay? So I is equals to integration root over 1 plus cos 2x divided by 2. Now since I have mentioned cos 2x has 4 formulas, I'll emphasize on the second and the third formula, okay? The second formula for cos 2x is 2 cos square x minus 1, and the third one is 1 minus 2 sin square x. We are going to use the second formula out here. That is this. Cos 2x is equals to 2 cos square x minus 1. We have already done this formula in class 11 also, and we have already done this formula in differentiation also, okay? It's not a new formula for you. So we're using the formula for cos 2x. Bring your minus 1 to the left hand side. So this minus 1 becomes plus 1. So 1 plus cos 2x, then the value becomes 2 cos square x, which is this. Okay, so 2 cos square x. Now what we'll do is, I'll replace the value for 1 plus cos 2x as 2 cos square x in the numerator out here. Then let's see what we get. Therefore I will be this integration root over the value for 1 plus cos 2x is 2 cos square x, and then divided by 2. 2 and 2 gets cancelled out, so I'll be getting root over cos x. Now this is a perfect square number, so this is cos x whole square. Square and square gets cancelled out, hence I get integration of cos x, and the formula for integration of cos x is sin x plus c. Please don't forget to write this plus c, which is the constant of integration. So pause the video to note down. Okay, so that was exercise 8.1, and now we are starting exercise 8.2. Okay, so in exercise 8.2 now we'll be learning to integrate a binomial expression or trinomial expression or polynomial expression. How? Let's see, okay? So evaluate the following integrals. So it is given out here, a quadratic expression is given out here, ax square plus bx plus c, and we have to differentiate this whole function expression with respect to x dx. Okay, now how will I integrate out here is, I can separate this just like opening the brackets, integration ax square dx plus integration bx dx plus integration c dx. So I can open and split it term by term. So therefore like this. Okay, so integration, keep your integration, and split it term by term. Ax square dx plus integration bx dx plus integration c dx. Now a, b and c are the constants out here which will be outside of integration now. So which means I'll be getting like this. A integration of x square dx plus b integration x dx plus c integration dx. Now we know the formula. X cubed by 3, we know the formula. X squared by 2, and we know the formula. I've given the last formula. Integration dx x plus another constant c1, which is this. So integration of x squared is x cubed by 3, x squared by 2, cx plus c. So pause the video to note down. So now we move to question number 3, part 1. Okay, the similar questions I've given homework. Don't worry, I'll mention the homework in the end. Okay, so 3 part 1, I have integration 2 cos x divided by 3 sine square x dx. So the first thing out here is we have to see the constant. So which is my constant? My constant is 2 by 3. So it will be automatic outside of integration. So therefore if I take this out, I'll be getting integration cos x by sine square x. Again the same thing. Remember the previous question we have done. Denominator was cos square x, and here the denominator is sine square x. So I can write sine square x as sine x into sine x and take this outside of integration. That is this. Okay, and now let's split it. Cos by sine means cot, 1 by sine means cosec. So hence I get integration of cosec x into cot x dx, which is the formula, isn't it? Which is the 10th formula. Integration of cosec x into cot x is minus cosec x plus c. So pause the video to note down. So the next question I am taking is question number 4 part 1, and the question out here is integration 2x minus 3 cos x plus e to the power x dx. So I hope now you people have guessed what we have to do. We have to split this term by term. So splitting term by term we get, integration 2x dx minus 2 integration 2x dx minus 3 is a constant, integration cos x dx, and integration of e to the power x dx, which is very simple. 2 is a constant, integration x dx, minus 3 is a constant, integration of cos x dx, and plus integration e to the power x dx. We all have the formula for this. So 2 integration of x is x squared by 2 minus 3 integration of cos x is sin x, and plus integration e to the power x is e to the power x. 2 gets cancelled out, and whatever you left out, that is our answer. I hope you're clear with this. So pause the video to note down. Question number 4 part 2, hint I've written out here. Please use the hint. So what will you do first is out here is x square into this, isn't it? So hence you can multiply term by term. Multiply x square, and when you multiply x square gets cancelled out, and then you can easily find the integration by splitting term by term. Okay, question number 7 part 1 now. Number 7 part 1 is ISC 2018. Okay, the question goes like this. Integration x cube plus 5x square plus 4x plus 1 whole divided by x square dx. So how will you do it now? There's a numerator and denominator. Here also what we can do is we can split term by term. Okay, let's see how. So splitting term by term, we will be getting something like this. Integration, and I'm separating integration and dx at the same time. Okay, integration first term by x square dx plus integration 5 is a constant, so integration second term by x square dx plus integration 4 is a constant, x by x square dx, and plus integration 1 by x square dx. I hope you people are clear with this. So here you can clearly see that x square and x square gets cancelled out, and here also x and square gets cancelled out, and here also I can cancel this and this, so it will be x. I'm showing this in the next step. Okay, that is this. So gets cancelled out. Integration x dx plus 5 is a constant, integration dx plus 4 integration, is it 1 by x after cancellation, into dx, and plus yesterday we have learned how to evaluate this type of integrals, isn't it? So make it in the form of x to the power n, so x to the power minus 2 dx, and now we simply use the formula. This is x squared by 2, this is 5x, plus this is 4 integration of 1 by x dx log x, and this one you know, x to the power n formula. Okay, so if you use the formulas, you'll be getting like this, and hence this is the final answer. So pause the video to note down. Okay, so out here, hints of some questions I've given out here. 7 part 2, this is the question. So how will you proceed? Separate or split term by term. X cubed by this plus 4 by this, and then separate your integration. You'll be able to integrate. Number 8 part 1, expand this expression first, okay, and then multiply by x square. Question number 8 part 2, you just have to expand and take the integration. Question number 9 part 1, expand with this formula and then split term by term. Okay, so all this question you can do it yourself, and I'm moving to the last question for today, that is question number 9 part 2. Okay, so 9 part 2, the question is integration x cube minus x square plus x minus 1 dx divided by x minus 1. Okay, so how to proceed in this question is that first thing we can see out here, x square is common, so I can take x square common. So if I take x square common, then I'll be getting x minus 1 plus 1 is my common factor in between these two. So if I take 1 common, within the bracket it will be x minus 1. So here is also x minus 1, here is also x minus 1. So I can take x minus 1 common in the numerator. So if I do so, then I'll be getting this, taking x minus 1 common, and remaining x square plus 1. Now x minus 1 gets cancelled out, and this is the remaining. Therefore integration of this is x square dx plus x integration dx, so which is x cubed by 3 plus x plus c. Okay, so pause the video to note down. So note down your homeworks from exercise 8.1, question number 4 part 2, from exercise 8.2, number 2, 2 part 1, 3 part 2, 5 part 1, 8 part 1, and question number 8 part 2. Okay, so that's it for today. So tomorrow we'll continue with our work.